This is Jee 2022. This is Jee 2020, paper 2, section 3. In this section, there are 6 questions. All of them are numerical value type of questions. You have to give your answer up to 2 places of decimals, and you have to make it round off as there is no negative marking over here. So let's represent this. So let's start our video right after this short break. And if you're first time on my video, then please like, subscribe, and don't forget to hit the bell icon button to get the video first.
Audio Jungle. Audio Jungle.
Question number 13. A spherical bubble inside the water has a radius capital R. Take the pressure inside the bubble and the water pressure to be P naught. The bubble now gets compressed radially in an adiabatic manner so that its radius becomes R minus A. For A is very less than R, the magnitude of the work done in the process is given by 4 pi P naught RA square X, where X is the constant and gamma is equal to Cp by Cv, 41 by 30. The value of X you have to find. In this question, what you have to do, as here there is a adiabatic manner, here it is given. So PV power gamma you have to use. So PV power gamma is equal to constant, and after differentiating you will get the relation between this one, right? So you can find dp by dv you can find over here as so you will by using this you can find the average change in pressure and change in volume, and with the help of this you can find the work done, as work done is required over here. So del P average, here you can use del P by 2 as pressure varies linearly over here. So for small changes, del P average will be del dP by 2 by considering the linear variation in the pressure. So let's go ahead. Here dV is equal to 4 pi r square A, PV power gamma is equal to constant. So taking log and differentiate over here, we'll get V power gamma dP plus P V power gamma into V power gamma minus P gamma V power gamma minus 1 dV. So in this way we can find dP is equal to minus gamma P dV by V. So minus gamma P naught 4 pi r square A upon V. Work done is W is equal to del P average into dV. Del P average, that is, as I told over here, dP by 2 you can use over here as pressure varies linearly. So gamma P naught 4 pi r square A, and 4 pi r square A here, this one is area over that, means change in volume over here, and upon 2V, that is the result. So finally what we conclude that here we get, after solving, we get 3 by 2 times of 41 by 30 into 4 pi P naught r square. So this much factor you have to find. So solving 3 by 2 into 41 by 30, you will get 2.05. So the final answer is 2.05. Let's go ahead for another question. Question number: in the balanced condition, the values of the resistance of 4 arms of Wheatstone bridge are shown in the figure. The resistance R3 has the temperature coefficient 0.0004 per degree centigrade. If the temperature R3 is increased by 100 degrees centigrade, the voltage developed between S and T, you have to find, will be itna volt. So how to find? As R1, R3, R2 and R4 is given over here. And temperature is 100 degrees centigrade, change in temperature. So you can use R equal to R0 1 plus alpha delta T. For this R0 will be considered as 300 ohm, R3 for given here. So evaluate R3 first. So let's start. R3 is equal to 300 into 1 plus alpha delta T. After solving you will get 312 ohm. So here that will be 312 ohm for this potential change, that is X minus 0 upon 312, and here plus X minus 50 upon 60. So sum of these two voltages will be there, and that is 0. And with the help of this you can find this value of X. So X will be over here nearly 41.93, and for this one Y, that is what we say for Y, that is 41.6 is how. Let's see, X is equal to 41.93 minus 41.66 at 0.27 is here. As how this comes, So if you see y minus 50 upon 100, you can say 1000 over here, and y minus 0 upon 5000. So you can say 500 after deleting one of the zeros. So get the value of y equal to 250 by 6. Nearly that is 41.66, and this way we can get x equal to difference of 41.93 and 41.66, that is 0.27. So the answer is 0.27. Let's go for another question. Question number 15. Two capacitors with capacitance C1 is equal to 200 plus minus 10 picofarad and C2 is equal to 3000 plus minus 15 picofarad are connected in series. As in the series, you should know that 1 by C equivalent is equal to 1 by C1 plus 1 by C2, and the change in potential, that is 500 error of the potential, that is 0.02 volt, as 5 volt plus minus 0.02 volt is given over here. Percentage error in the calculation of the energy stored in the combined capacitor you have to find. So what is the combined energy? That is half of CV square. So V net you have to find, as you know, that is with the help of combination of the capacitance you can find this, and by using this one differentiation of the formula 1 by x, you should know that minus 1 by x square, you get the dc by c1 is equal, dc by c equivalent is equal to dc by dc1 upon c1 plus dc2 by c2 square, and c1 square here also there. So let's go ahead. So total net energy is half of C naught B square. Meanwhile, calculate either 1 by C is equal to 1 by C1 plus 1 by C2. You get C equivalent is equal to 1200. And by using this formula, 1 by C is equal to 1 by C1 plus 1 by C2, and differentiating both sides, you get DC by C square is equal to DC1 by C1 square plus DC2 by C2 square. So one of the C you use over here, cross multiplication, DC1 upon C1 square plus DC2 by C2 square into C. So that is DC by C. Here DC by C is equal to substituting this value of DC1 and C1, DC2 and C2 over here, and C, that is 1200 picofarad, whatever that is. And here that is DC by C, 10 by 4, 15 by 9, 1200.9 positive, just simple calculation. DC by C you can evaluate here. By using this one, D by E is equal to, as you know, del E is equal to half of CV square, and differentiating, that is square differentiation is 2x, so 2 del V, and dividing, that is V. So finally what we say here, del E by E is equal to, substituting the value DC by C and 2 del V by V over here, that is 4.17 into 12 upon 10 power 4 and 2 into 0.02 into 5 into 10 power 2, you can say 100 also. 50.64 upon 10 power 4 plus 4 upon 5 into 10, 100. Substituting this all, we get the 1.30, that's the answer. Now just another question, question number 16. A cubical solid volume Buck modulus is minus V dP by dV, 70 gigapascal, and block head that has an edge of length 1 meter on the surface of the earth. It is kept on the floor of 5 kilometer deep ocean. Taking the average density of the water and the acceleration due to gravity is 10 power 3 and 10 meter per second square respectively. The change in the edge length of the block in the millimeter is okay. So for this cubical volume, you can use this V is equal to L cube. You can differentiate here. You get the value of dV over here, and this is the Buck modulus. B is equal to minus V dP by dV. Magnitude you can consider over here, and then solve this. Let's go ahead. B, as we know, V is equal to dP by dP, dP by dV. Substituting the values, dV by V you relate, and V is equal to L cube, that is dV by V, differentiation of L, that is 3L squared dl. So to related here, that there is 3 dl by L, and that what we say here, 3 dl by L is equal to 5 by 7000, and substituting this all dl you get 0.238. So you can use 0.23 or 0.24, that both answer will be considered as correct. Question number 17, that is the mutual inductance is given L1 and L2, that is 10 millihenry, 20 millihenry is given here, resistance R1 and R2. Here two circuits are given. What they are telling about this means here that is a one inductor, two inductors are there. Mutual inductance is also working, and self-inductance is also working, and resistance LR circuit is given. So two LR circuits are placed in the next to each other as shown in the figure. The values of the self-inductance of the inductor, resistance, and mutual inductance and applied voltage are specified in the given circuit. Okay. After both the switches are closed simultaneously, the total work done by the batteries. Directly you can use the formula also here, or you can evaluate the work done over here. So better just to go ahead by using electromotive forces. E1 is equal to, and that is L di by dt, and that is M di by dt. So using this you can find the work done. Now what we show over here, what we see over here, that is E1 is equal to L1 di1 by dt and plus m di2 by dt. In this case, we have to consider di2 by dt. So here what we say here in second case is, on the second circuit also you can apply here. So that is E1 is equal to L1 di1 by dt and m di2 by dt. So dw is equal to E1 I1 dt, and similarly dw2 is equal to, what do you have to say? So for dw1, what do you get here? For E1, you use this one, this all formula. So L1 di1 by dt and dt, this is all related. So E1 I1 di1 and m di2 into I1. So like this way you have to write, and just if you interchange this all for the another circuit, for this one another circuit, you have to write E2 is equal to L2 di2 by dt, right, plus m di1 by dt. So simply you will get here dw2 is equal to L2 di2 I2 into plus m, here you get di2 into I2 and m di1 into I2. You just change the value of, instead of 1 and 2, you have to exchange this 1 and 2. For 1 you have to write 2 and for 2 you have to write 1. You will get the for the another circuit. So from 0 to w, entire work done dw1 plus dw2 is equal to integration of this all addition. So what do we find over here? 0 to I1 L1 di1 I1, L2 di2 I2, and m, that is di1 I2, both of them. Okay, so what do we conclude over here? So half of Li square, half of Li L2 I2 square, and m I1 I2, integral of one is, that is simply x. So substituting the value, you get 55. And now question number 18. Come to another question. A container with 1 kg of water is kept in the sunlight, which causes the water to get warmer than the surroundings. The average energy per unit time per unit area received due to the sunlight is 700 watt per meter square, and it is observed by the water over an effective area 0.05 meter square. Assuming that the heat loss from the water to the surrounding is governed by Newton's law of cooling, the difference in degree centigrade is the temperature of the water and the surroundings after a long time will be dash. Ignore effect of the container and the constant of Newton's law of cooling. So is this such given? Heat capacity of water is 4200 joule per kilogram per Kelvin. As this problem is from Newton's law of cooling, the Newton's law of cooling formula, you have to use this all. Let's start. dq by dt is equal to E sigma A T power 4 minus T naught is to the power 4, and that is A area cross section, at E sigma A T cube upon mc, that is constant for Newton's law of cooling, which was given over there 0.01. So mc dt you can use over here, dq is equal to mcv dt, and mcp dt you can use, that is cv also, and dt by t, that is E sigma A T cube mc delta t. Substitute these values, so we find E is equal to E sigma A T cube is equal to mc 0.001. Substituting these values over here, C is given in the question 4200. Substitute over here, this is question 1, 2, let and dq by dt is equal to 700 into 0.005, 35 watts. So substitute this 2 from equation 2 and 3 in equation 1. So in equation 1, that is dq by dt, and here you get this value del t. So del t, that is from here you can find 0.001. So directly you can use over here. That is 0.001, this one. So substitute this value over here. So from here, what do we find? 35 is equal to 4.2 into del t. In this way, you can find del t is equal to 8.33. And that's your answer. This is the complete solution over here. And that is the end of the paper 2. And if you find any difficulty, you please write the comment, and I will respond here to each and every comments. So without hesitation, you please give your feedback also, how you like, and if you like it, then please like and share also, and subscribe my channel to get new videos ever first. Thank you.